Okay, welcome back.
Yeah.
Mr. Willis. Section 34.1, page 992. We're talking about the circulatory system today. And what it does, this is the system of your body that's in charge of moving blood around, and as the blood moves around your body, it transports oxygen and nutrients to your cells. So every cell in your body has to get oxygen and food, and it's brought to them by the blood. Yes.
I'm prepared. How student are you?
The blood carries disease-fighting materials produced by the immune system, like antibodies. They float around in your blood and fight any invaders that get inside your body. There's lots of microscopic little organisms that would love to live inside you. But the blood carries around chemicals and proteins that kills those things. Contains cell fragments and proteins for blood clotting. The blood can clot, so if you're bleeding out, it stops shortly. And distributes heat throughout the body to help regulate body temperature. So if the blood goes to an area, the area becomes warmer. And the body can squeeze off and loosen up blood vessels to distribute blood to different places. And here are the three types of vessels that we have: arteries, veins, and capillaries. Capillaries are real tiny vessels, the smallest in the body. Every cell in your body has a capillary near it. And capillaries deliver blood, and the walls are very, very thin. So the blood goes through the middle, and stuff can leak out through these little cracks between the cells. And so if the blood's carrying oxygen, oxygen goes right through to the cells. Or food particles. You can see veins and arteries have thicker walls. This area here, that's muscle. See, smooth muscle. Remember I said arteries can close off and pinch off to keep blood from going to some place? That's what that muscle's for. And veins can also do it to some extent.
Why would you want that?
Well, for instance, if it's cold out, and you don't want your blood getting cold, so the little arteries that go to your skin will close off and keep blood from getting to a cold area. Keep blood down deep so it stays warm. Make sense? And that's why you lose feeling in your fingers and toes when it's cold out, because blood quits going to the fingers and toes. We call it an artery if it goes away from the heart, and a vein goes back to the heart. So arteries are the ones where you can feel a pulse. The heart pumps and pushes blood through the arteries, and you can feel it pulsing against the vessels. As it comes back through veins, and it comes back kind of slowly. The veins don't have nearly as much pressure as the arteries. If you cut an artery, blood would spurt out. Every time the heart beats, some blood would spurt out. If you cut a vein, blood just kind of oozes out because it's farther from the heart, see, on its way back. Video footage.
Video footage of an artery getting cut?
Veins and arteries.
At the center of our fluid delivery system, the blood circulation. Under pressure from the heart, the blood flows outwards in the arteries, the red tubes here, and back along the veins, the blue ones, after it's delivered its supplies to the cells. The widest artery is the aorta, with a fibrous muscular wall which receives the full force of the blood as it first leaves the heart. Then, as the blood travels through the body, the arteries get narrower and divide up into smaller and smaller tubes, carrying off the blood supply to different organs. Up to now, the tubes are still just a transport system. But as the blood reaches its destination, the blood vessels become leaky, so that the food, oxygen, and other components can get through to the tissues. These are the capillaries, and they're so small that more than 1 million of them would fit into the diameter of the aorta. Now that the blood has delivered its supplies, it travels back in the veins towards the heart. The blood is no longer under much pressure, and the veins have thinner walls without much muscle. They also have valves in them to help the blood on its sluggish way back to the heart. The important thing about blood in the body is that it's a closed system. The blood gets used over and over again.
Isn't that great?
The best thing I've ever seen.
So here it shows the veins, like it said in the video, the veins have little valves in it. That's a little one-way valve that keeps blood going in the right direction. Because it's so far from the heart's pump, it has trouble moving, and the valves keep it from going backwards. See what this is?
The walls of arteries and veins have 3 layers. The lining consists of endothelium, a simple layer of cells. The middle layer consists of smooth muscle and elastic fibers. The outer layer is made of connective tissue with elastic fibers. Capillaries have only a single endothelial layer. Blood returning to the heart through the veins after passing through the capillaries is under much lower pressure than the blood flowing in the arteries. Veins have thinner walls with less muscle and elastic tissues than arteries. Valves in the veins prevent the blood from flowing backward.
Okay, that was pretty bad. That's horrible. Now, here are the parts of the heart. And this is on page 995.
Do you ever produce more blood?
Yes, blood is made in your bones, in your the bone marrow of your bones. And so it's always produced. You have blood cells are always dying and new blood is always being produced. Blood cells live about two or 3 months. And then they die. And they tear up. And the liver kind of destroys them. The spleen is another organ that will tear them apart after they're messed up. But they're constantly being created in the bone marrow. Okay, so here's the heart, and the heart is, humans have a 4-chambered heart, 2 chambers on the top, those 2 right there, 2 chambers on the bottom. The chambers on the top are called atria, the chambers on the bottom are called ventricles. And what you have to know for the essay for this chapter is the path of blood flow. If you start at one area of the heart, let's start at the right atrium, and go all the way back to the right atrium. That's your essay, part of your essay. Okay? So here's how it works. Blood comes into your heart. Thank you. Will you shut the door for me? Thank you. Blood comes into your heart through these 2 vessels. The superior vena cava, that's this one, and the inferior vena cava, that's this one. Those are the biggest veins, and these veins lead to the right atrium. Now notice it's called the right atrium. That's this part of the heart. If you look at it, it's on the left side. But if it was my heart, and I'm sitting here facing you, it's on my right side. Okay? A lot of people screw that up. They get it backwards because they're looking at it, they think it's on the left. That's the right atrium. Understand? So blood goes into the right atrium. The right atrium squeezes. Blood is pushed down through this valve called the tricuspid valve and down into the right ventricle. This is the right ventricle on the bottom. Now that's a one-way valve, so blood cannot go backwards. Once it's in here, it can't go backwards through that valve. It's kind of like a one-way door. You know, like this little turnstiles you go through at the ball game. You can't go back once you're through. You gotta go around. So now we're in the right ventricle, and the right ventricle will squeeze. So the blood squeezes the top first, squeezes it down, then the bottom squeezes it back up, but it can't go back into the right atrium. It's got to go up this way to the lungs. And these are arteries called pulmonary arteries here, and as you can see it branches off and goes this way. This right pulmonary artery goes to the right lung, and the left pulmonary artery goes to the left lung.
So that's basically our essay right there.
I'm working on it right now.
Still not half the heart.
Yeah.
No, I know, but like that diagram, that's always. Like,
No, that's not it, but it's a good part of it. It's not everything, but it's. If you know all this, you're on your way.
Okay.
Okay. So, just review real quick. Blood goes from the body through the superior and inferior vena cava to the right atrium, gets squeezed down through the tricuspid valve to the right ventricle, then gets squeezed up through the pulmonary arteries to the lungs. Now there's another valve right there. See that little valve? That keeps blood from going backwards back into the right ventricle. That valve is called the pulmonary valve. So the word pulmonary, if you see the word pulmonary, that means lungs. So the pulmonary valve is the valve that's leading to the lungs. The pulmonary arteries are going to the lungs. What would you call a vessel coming back to the heart from the lungs? What kind of vein? What
Aortic.
coming from the lungs, so it's pulmonary vein. Exactly. Got it. So after the blood gets in the lungs, what's it doing in the lungs, by the way? Picks up oxygen. The lungs are for picking up oxygen, so the blood goes to the lungs, picks up oxygen, and then comes back. If you'll notice, the blue vessels mean there's no oxygen. Blood turns kind of bluish in color if there's no oxygen. And then when it picks up oxygen, it turns red. Stay with me here, Tug. And so the blood coming back from the lungs is red. It's oxygenated blood. And comes back through the pulmonary veins. And there's some over here too. The right pulmonary veins and left pulmonary veins lead to the left atrium. That's the top part of the heart on the left side. And then the left atrium gives it a squeeze, and that pushes the blood down through this valve called the mitral valve into the left ventricle. And then the left ventricle gives it a big squeeze, and that pushes blood up through another valve called the aortic valve into this huge vessel here called the aorta. It's the largest vessel in the body. That's a big artery that leads away from the heart. And the aorta takes blood to everywhere in the body. It has branches. See some branches here that go up to the head. It has another big curling branch that goes down to the trunk of the body and the legs. And then eventually the blood drops off its oxygen and then comes back up from the legs through the inferior vena cava to the right atrium, or through the superior vena cava to the right atrium. That's a lot of stuff. Can you remember all that?
Yeah, you got it memorized.
Have you ever had that before?
Yeah.
Well, not as detailed.
More than
You had that in middle school?
Yeah. Tucker taught us stuff.
Good.
8th grade, I think.
It's hard if you've never seen any of those words before. It makes it a little easier if you know more about it. So, real quick, superior inferior vena cava into the right atrium, down through the tricuspid valve, into the right ventricle, up through the pulmonary valve, through the pulmonary arteries to the lungs, pick up oxygen, back through the pulmonary veins to the left atrium, squeeze down through the mitral valve to the left ventricle, back up through the aortic valve to the aorta, and to the rest of the body. Yay! That's a good portion of your essay. Want to see video footage? Oh, I just happen to have 9 videos.
We gonna watch on that?
This is from the AP Biology book, but it's showing the same stuff. It just has a better look of it. It shows the valves better.
Ventricular contraction causes the atrioventricular valves to close, which signals the beginning of ventricular systole.
do the talking here.
It's ventricular system.
Yeah, don't worry about what.
Systole is a squeezing. Systole squeeze. So you can see the atria squeeze and push blood down there. That's not a very good video. Here's a good video. This shows for real. What? That's a heart.
Do it again. Is that your heart?
Yeah, that's mine.
Yeah, I thought it looked like it.
How do we not feel that like beating in our chest?
You can feel it.
Sometimes, but how come like is it usually going that like intensely?
Yeah.
Taylor because it had a few.
Goes that intensely? That's an open heart surgery. Sometimes they got to open up the chest and do surgery on the heart. I'll show you a heart surgery in a minute.
Does it make that noise?
Yeah.
Whoa, that's not good.
That's a microphone stuck real close to it. Turned up, volume turned up. So it's actually not that loud, but
Yeah. It's exactly what it sounds like.
I really like it. They're like, hey, this guy's got a
this is the effect of epinephrine. They inject it with adrenaline and it speeds up.
Just for our
Hey, pro.
Yeah.
Is like bypass surgery, that heart surgery?
Yeah?
What does that mean?
That means there's been some kind of, on the surface of the heart, there are vessels and sometimes they get blocked. You have to take another vessel that you can usually cut out of somebody's leg and bypass the blockage. So you attach the vessel to one end and the other end so the blood goes around the blockage.
How do you attach a vessel to another blood?
You sew it on there.
My grandpa got that.
Yes.
What do you do with what's the metal thing that some people have?
Pacemaker.
Yeah.
I should talk about that in a
It's
minute.
in our book.
We,
Actually,
that's next.
Stimulating a nerve called the vagus has this effect.
Oh.
That sounds.
Are they just messing with this guy's heart?
Yeah.
Okay, we're gonna make this guy host.
You're doing fine release for
Probably.
You guys like wish like, oh, it's my heart. It's like watching the videos like biology teachers.
This valve opens during contraction, closes during relaxation.
That's the pulmonary
Blood in the
valve.
pulmonary artery flows back against the flap.
It's what's going through it.
They've taken out the blood and put it in a clear fluid so you can see the valves. Some people have problems with their valves.
This valve opens during contraction, closes during relaxation, as blood in the pulmonary artery flows back against the flap.
What they do when they're doing heart surgery, they run all the blood through a machine. It's called a heart-lung machine. And let that kind of move the blood for you so that they can work on the heart without a bunch of blood everywhere so they can see. And so they can put clear fluid in there that's like water and it's still, and the heart is still moving the water around and stuff, but they can see as they're working.
Could you like live off that machine? Like if they can
Yes.
heart for you?
Yes?
Like
T
you
shots?
like an oxygen machine?
Yes.
Like ice, man.
Like T-shots.
Here's another valve.
Here's the action of the tricuspid valve as the heart is made to contract and relax.
That's the
That
tricuspid.
looks a little blue.
See why they call it tricuspid?
Here's the action of the tricuspid valve as the heart is made to contract and
3
relax.
cusps.
I say 4 or 5.
3 big ones.
That's good stuff.
The heart has 4 chambers: the right atrium, right ventricle, left atrium,
Now this guy's got boring voice, but this shows really good how the heart makes sounds and how the blood moves. If you were to write what this guy's saying, you would have a good essay here.
Yeah, that's a boring voice.
Sorry he has a boring voice, but it's good.
and left ventricle. The chambers on the right are separated from those on the left by the interatrial and interventricular septa.
Each side of the heart functions as a separate pump. Oxygen-depleted blood from the body flows into the right atrium through the superior vena cava and inferior vena cava. Freshly oxygenated blood from the lungs flows into the left atrium through the pulmonary veins. When the heart is relaxed, the atrioventricular valves open, allowing blood to flow from the atria directly into the ventricles. The atria contract, forcing additional blood into the ventricles. The ventricles begin to contract. Pressure rises within the ventricles, forcing the atrioventricular valves to snap shut. The first sound is produced. As contraction continues, pressure forces the semilunar valves to open. Blood is ejected from the right ventricle into the pulmonary trunk and from the left ventricle into the aorta. As the ventricles relax, back pressure causes the semilunar valves to snap shut. The second sound is produced. Pulmonary arteries carry oxygen-depleted blood to the lungs. Systemic arteries carry the oxygenated blood from the aorta to the body. In review, blood flows into the atria, then through the open atrioventricular valves and into the ventricles. The atria contract, forcing additional blood into the ventricle, to the pulmonary trunk and the aorta. Ventricles relax. Back pressure.
Now here they're going to show that the way the heart makes sounds. Have you ever listened to a stethoscope and hear your heartbeat? The sounds come from these valves. And this shows real good the sounds that are made.
Forces the semilunar valves to snap shut. The second sound is produced.
Watch when the valves shut, you hear the sounds. You see? And both sides are working at the same time.
That's just messing with them.
So the sounds are made by the valves shutting.
Yeah. I feel like they run like hot
See what this is?
I like how they sound like church. Do they make churches?
Yeah,
What? I feel like I saw
No, they made a pirate business.
was like Moses.
Oh, yeah.
Heart
The
surgery.
human heart is a magnificent and complex structure that beats approximately 70 times per minute. The regular heartbeat is under control of the pacemaker that faithfully sets, adjusts, and resets the rate at which blood is pumped throughout the body. Sometimes disease or injury interferes with the heart's normal activity. More than 40 million Americans suffer from a variety of cardiovascular diseases, which claim approximately 750,000 lives per year. Modern surgical techniques allow for the correction or control of many of these disorders. During surgery, the patient's blood is routed through a heart-lung machine, which removes carbon dioxide and adds oxygen, bypassing the pulmonary circulation. Free from its normal activities, the heart can now be exposed to the outside and corrective surgery performed. During surgery, the heart is constantly monitored, both externally and internally. Even though many heart disorders are treatable, many are preventable by a healthy diet and routine exercise.
That was so good.
This is blue and orange fuzz.
Everybody know how to take your pulse? Here's the corner of your elbow here. You just kind of take two fingers and put it right below where the bone here is, and you should be able to feel a little pulse.
Bro, I don't have a pulse.
That's proof that you're alive.
Bro, I don't have a pulse.
You might not be alive. You might be a zombie.
Yeah.
Agreed, for my pulse.
So your blood pressure is basically a measure of how hard the blood is pushing against the walls of the vessels. And some people, a lot of people in America have high blood pressure. High blood pressure comes from a lot of things, but it's mostly from bad diet. You eat too much salt and you don't exercise enough, the insides of your vessels become clogged, and the blood really pushes hard against the walls of the vessels. You can get your blood pressure measured in one of those cuffs. Have you ever seen those in the stores?
My mom.
And for people your age, it should be about 120 over 80. Some people have it all the way up to, 200 over 140. Just way too high. And people with high blood pressure usually die pretty young. Question?
My doctor said that I faint easily because I have low blood pressure.
Low blood pressure.
Why would that make you faint?
Well, it's not getting enough blood to your brain. If your pressure is low, it's like turning on a hose not very hard. The blood's not going through there very fast. So you want the pressure to be up enough so it gets everywhere in your body. The problem if it's too high is it's pushing so hard on the walls of the vessels, sometimes it'll break open the vessels. And if the vessels burst, it's called a stroke if it bursts in your brain, and it's called a heart attack if it bursts on the surface of your heart. So those aren't good things. Yes? An aneurysm is when a blood vessel breaks. And often it happens in the heart or in the brain. Okay. We can see the circulation here. Again, the blue is deoxygenated. The red is oxygenated. So when the blood comes from your left ventricle, it's oxygenated and it goes everywhere in your body and delivers its oxygen. So here it goes from red to blue, and now it has to come back to the heart, get pumped to the lungs. This shows the lungs up here, where the blood goes back from blue to red by picking up oxygen.
Bro, I have a question.
Yes?
Is the assay the blood through the heart or through the heart and the body?
The assay is the heart and body.
Okay.
But basically it's just an extra sentence or so talking about the body.
If you were to trace the path of a drop of blood through the heart, you could begin with the blood coming back from the body through a vena cava. The drop travels first into the right atrium, then to the right ventricle, and then through a pulmonary artery to one of the lungs. In the lungs, the blood drops off its carbon dioxide and picks up oxygen. Then it moves through a pulmonary vein to the left atrium, into the left ventricle, and finally out to the body through the aorta, eventually returning once more to the heart. Between the atria and the ventricles are one-way valves that keep blood from flowing back into the atria. The heart is enclosed in a protective membrane called the pericardium.
When is our test? This week or next week?
Check your syllabus on that.
It's Friday?
I think it's Monday.
Now,
No, I hate Monday tests.
this yellow thing right here, listen. The yellow thing is the electrical conduction system, called the cardiac conduction system. It has this part of the heart right here, this is called the SA node. That's your pacemaker. And the pacemaker sends out an electrical signal that spreads over the top of the heart and makes the top of the heart squeeze. And then the electrical signal is picked up and runs down like this and comes back up, and then the bottom of the heart squeezes. So there's an electrical system belonging to the heart that runs the heart's pumps. The top part squeezes, then the bottom part squeezes. And this is why a heart can beat on its own without the brain. If you've ever seen a ninja pull a heart out of somebody's body, it'll beat on its own for a while because it's got its own cardiac conduction system there.
Are you saying everybody has that? Or when
Everybody has that. This is automatic. Some people, their SA node, this is the pacemaker, doesn't really work right. And so they have to get an implanted pacemaker to help theirs if the pacemaker's not working.
Is that what a regular heartbeat is?
What's that?
Is that like
I'm good. I'm good.
Yeah, it could result from something wrong with the pacemaker.
What's a heart murmur?
Action potentials originate in the sinoatrial
Quiet,
node
please.
and travel across the wall of the atrium from the sinoatrial node to the atrioventricular node. Action potentials pass slowly through the atrioventricular node to give the atria time to contract. They then pass rapidly along the atrioventricular bundle, which extends from the atrioventricular node through the fibrous skeleton into the interventricular septum. The atrioventricular bundle divides into right and left bundle branches, and action potentials descend rapidly to the apex of each ventricle along the bundle branches. Action potentials are carried by the Purkinje fibers from the bundle branches to the ventricular walls. The rapid conduction from the atrioventricular bundle to the ends of the Purkinje fibers allows the ventricular muscle cells to contract in unison, providing a strong contraction.
Okay, that was a lot of words that were hard to understand, but you can see this electrical signal goes through. It starts from the top, right up here in the right atrium, and spreads through the heart. It does that about once a second. Your brain can speed that up or slow it down by sending signals to it, telling it to speed up or slow down. But it'll do it on its own. This is why people can survive if they're brain dead. Your brain can be totally dead. The cells up there just totally not working, maybe because of a stroke or something like that. But your heart will still beat on its own and will still move blood around the body. And so people's brain can be dead when all the rest of their cells are alive. This is a little measure of the electrical impulses running through the heart. And you get a little wave called the PQRST wave. And this little bump right there is the measure of the contraction of the atria. And that big bump there is a measure of the contraction of the ventricles. And if you're hooked up to a machine in the doctor's office, every time it hits that top peak there, it'll beep. And so you hear a person on a heart monitor machine, it goes beep, 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 every time the heart beats. That T wave right there is the relaxation of the ventricles. Yeah?
What's a heart murmur?
A murmur is when the blood is going through the valves, and then the blood goes through the valves open, and then when the valves shut, some of the blood leaks back through the valves. That's called a heart murmur.
Would it look different on
I thought it was like...
It doesn't have to do with the electrical system. It has to do with the sounds the heart makes if you listen to it.
I thought it was like when your heart skipped a beat or something.
No, that's not. A murmur has to do with the
Just like an irregular heart.
with the valves. Here is an irregular. Here is a heart not working, and you often have to give the people a shock if their heart's not working right to get the electrical system back going again. So they hook those big electrodes up to them and give them a big shock. That stops the heart for a second, and then hopefully the heart will get going again. This is a table showing all types of stuff that's in the blood. The blood has a lot of water in it, proteins, salts, oxygen and carbon dioxide gases, a lot of nutrients. These are food, lipids, glucose, amino acids, food. Has nitrogen waste, it has hormones and vitamins. The blood has a whole lot of stuff in it. And here's what the cells look like under a microscope. These little pink circles are red blood cells. And these big purple ones, those are white blood cells. White blood cells fight diseases. They crawl around your blood looking for anything that doesn't belong there, and they'll eat it up.
Like osmosis shows.
How do you make white blood cells? Is that in the bones?
That's made in the bones too.
Isn't there like, when people get like the cancer of the bone marrow, they can't make white blood cells, so they die usually like of like
Yeah, that's
common sicknesses like a cold or something?
yeah. If you're not making enough white blood cells, you've got problems. And sometimes the white blood cells start multiplying out of control. That's a type of cancer. So there's all sorts of things going on with that. There it shows all the different types. And platelets. Platelets are little pieces of cells that cause blood to be able to clot. Blood comes in blood types, type A, type B, type AB, and type O.
Are we gonna figure out what kind of blood type we are?
We are not. But here's how it works. Type A blood has certain proteins on its surface, A proteins. And type B blood has different proteins, B proteins. And type AB has both types. And type O has neither type. Now there are also antibodies in the blood, and they show the antibody. A person with type A blood has anti-B antibodies. That means if you put a cell with the little B protein in a person that's A, the anti-B antibodies will destroy it. So a type A person cannot get either B or AB blood put in their bodies because their anti-B antibodies will destroy it. So we call type O the universal donor because it has no proteins on its surface. So you can give this cell to anybody because their antibodies will not destroy it. Question, Tom?
No, I'm good.
Is it bad to have type
Pro? The O doesn't it say it has antibody A and B?
Yes, you can't give any of these blood types to a type O person because they have both antibodies and their antibodies will destroy all three of them.
Rarest kind too.
Type O is the most common kind. 50% of people have type O.
Mr. Weller, so if you had
The rarest is AB.
if you had type A and you need like more blood, you'd get it from type O.
You could get it from type O or type A.
On the bottom it says can receive blood from.
Yeah, can receive blood. Does that make sense?
That wasn't a new one.
Here's what it looks like when blood is clotting. These little lines are special fibers that form kind of a mesh, and if you cut yourself, these little fibers form that capture the blood cells and form a scab is what this is. And these little fibers are formed from little tiny pieces. See those little pieces? They just float around in the blood, but whenever there's a tear, the little pieces come together to form these bands. It's a really sophisticated system that's hard to understand. Here's an incredible video about a heart surgery. Shocking video.
From the heart of Siberia, a heart-stopping operation you'll never forget. Each year in the United States alone, over 700,000 people undergo open-heart surgery, a procedure that requires the heart to be stopped. Thankfully, in this country, we have heart-lung machines to take over the functions of the heart while it's stopped during surgery. Outside of Western medicine, in places like Siberia, doctors can't afford these multi-million-dollar machines. So they use a natural resource found right outside their window: ice. It's the key ingredient in a radical form of open-heart surgery. The ice cools the patient's body, plunging it into a deep freeze until all the vital organs shut down, and they are clinically dead. This astonishing technique was pioneered by Russian surgeon Elena Latasova.
There are many advantages to ice surgery. We're not dependent on donor blood. We're not dependent on expensive machines. And we rarely have complications.
This is the story of 10-year-old Vika. Vika traveled hundreds of miles from her home to undergo ice surgery. She has 2 large holes in her heart that are threatening to kill her. Her activities restricted, Vika has become a prisoner of her heart condition. She hopes the surgery will free her to enjoy the one thing she loves most.
My mom doesn't allow me to dance because I can get sick.
December 4th, 1998. Little Vika is anesthetized and wheeled into the operating room, where a medical team, including Dr. Dmitry Gubakov, goes to work, packing her body in ice.
We use about 50 pounds of ice per standard kit. So we use very fine crushed ice, specifically prepared very thin pieces of ice, almost snow.
Vika will slowly be frozen to death. Her core body temperature will plunge from a normal 98.6 to a deathly 71 degrees. Drugs have been infused to combat frostbite and protect her vital organs from being damaged. After 20 minutes of being packed in ice, her vital organs have shut down. Vika is nearly dead. She is only a heartbeat away from the grave. Surgeons are now racing against the clock because Vika's vital organs can only survive for about an hour in this frozen state. All the ice is removed except the frozen helmet around her head.
The ice on the head stays when the ice from other parts of the body is removed. It gives us additional protection of the brain.
By lowering the brain temperature to 59 degrees, it protects against the risk of permanent brain damage. Once all the ice is removed, doctors open her chest to start fixing her diseased heart. Clamps are attached to the major arteries, choking off blood flow to her heart. Then a drug is administered to stop the beating. Vika is now clinically dead. Dr. Elena Latasova quickly begins to patch the holes in Vika's heart. If she remains in cardiac arrest for too long, doctors may be unable to bring her back to life. Amazingly, the medical team is able to complete the surgery in 20 minutes. Now comes the most difficult challenge. Doctors must restart Vika's heart and literally bring her back from the dead. In an attempt to jumpstart Vika's motionless heart, Dr. Latasova takes it in her hand and begins massaging it. After a few minutes, the heart responds, but it's sluggish and beats irregularly. While Dr. Latasova continues the heart massage, warm water is poured directly onto the heart to stimulate blood flow. Still, the little girl's heart cannot maintain a regular beat. In a last-ditch effort, Dr. Latasova manually stimulates the heart by tapping it rhythmically. As they continue to beat the heart, doctors remove the ice helmet to speed up thawing. What seems like an eternity is only 5 minutes. Miraculously, Vika's heart comes back to life. The chest cavity is closed. Vika is wheeled back to her room to finish thawing. The first 24 hours are the most critical. As her body continues to thaw, her vital signs are carefully monitored through the night. Vika is barely clinging to life, and her parents spend a sleepless night anxiously awaiting word of her condition. Remarkably, the next morning, Vika is sitting up in bed playing, seemingly unaware of the shocking surgery she underwent. Surgery that took her to the grave.